Welcome everyone to the Packet Tracer for CCNA series, and we are all the way up to Chapter 14. And as you might recall from the textbook, Chapter 14 is our look at the components of routing tables. So we are asked to access the CLI on R1 and use the enable command to enter privilege mode as our first step. So let's go ahead and jump in and do that. So enable, and we are in privilege mode, and step 2 wants us to do a show IP route. Yeah, this is of course how we would look at the routing table on a Cisco device. And step 2 says, notice how this route table does not include any dynamically learned remote routes. Yeah, so we have these local connected entries. Notice there is a 32-bit entry for the full IP address of the interface in the case of loopback 10, and then there is the subnet entry for loopback 10. And we have the same situation going on for our gig 0/0 interface. So no dynamically learned route information as the lab indicates. Okay, so we are then going to issue the configure terminal command to enter global configuration mode. And we will now configure dynamic routing on the device. And we're going to be doing a lot more with that in Chapter 16. But we are going to get a taste of it here. We're going to say router OSPF, and then we give the process ID for OSPF running on this router. This process ID would not have to match between two neighbors for a peering to form, but in the case of single area OSPF, which is what you would be responsible for in CCNA, my goodness, you would want this process ID to match your other OSPF speakers, or things could get real confusing when you're trying to do your configurations, that's for sure. Imagine having to remember what you named the OSPF process on each different device. That would be a nightmare. Okay, so now we are in router configuration mode. And what do we need to do next? We are going to use the network command. So we're going to be looking at this in greater detail with OSPF, of course, but just so you know, what we can do with this command is specify what interfaces are going to run OSPF. So we indicate that if the interface falls in the 172.16.1 range, then we want OSPF running there. And we use a wildcard mask, the opposite of a subnet mask. In fact, it's often called an inverse mask. And what it's doing is, where we have the all zeros is the portion of the IP address we care about. Yeah, we end up putting a 255 all ones in the octet for that portion we don't care about. So what this is truly saying is, if our interface IP address begins 172.16.1, we don't care what is in that fourth octet, then run OSPF. And oh, by the way, it's OSPF area 0 that you need to be running. So notice what's going to happen. This command should enable OSPF on our gig 0/0 interface because there is a match there on that IP address. So I'm going to hit enter, and we now know in the background we are running OSPF on gig 0/0. Sure enough, look at this, we have formed an adjacency with another device. So sure enough, with the gig 0/0 interface now running OSPF, sure enough, didn't take long, we already formed a neighborship out of that interface. And the neighbor has a router ID of 10.20.20.2. That sounds like R2 to me. Yeah, so we are now all of a sudden magically peering with the R2 device. How cool. Now, The next step, step 6, has us continue with the configuration of OSPF. Yeah, what we're going to do is use another network statement, and this time we're going to say, if your IP address begins with 10, we don't care what is in the next 3 octets, you're going to be running area 0. This clearly is to catch loopback 10 and make sure that loopback 10 is also running OSPF. Well, they now want us to end our configuration, and we are now going to do a show IP route. And this is because now we should know of our dynamic remote routes. Let's do it. Show IP route. And look at this. We have the OSPF learned route of the 10-20-20 network. We have the OSPF learned route of the 10-30-30 network. We have the OSPF learned route of 192.168.1. As a matter of fact, as a little bonus for you, let's go ahead and teach you a little bonus command here that was not brought up in this chapter review, but this is a great trick. If you want to look at your routing table, but trim it to just the OSPF learned routing information, yeah, no problem. You can say show IP route and then add the OSPF keyword. This is going to be very handy, isn't it? Allowing us to just see the dynamically learned route information and not have it, be kind of lost in all of the local route information. Now, one of the things we need to do here, of course, is a copy run star to save our configuration, or as you know, I like to do the much easier WR, which will work in your exam environment. So what did we do in this exercise? We took a look at turning on dynamic routing on the R1 device so that we could learn dynamic route information. As a last point of review for this chapter, let's go ahead and walk through one of these dynamic entries to make sure we know what each component is telling us. So notice the first entry in a routing table entry is just making sure that we know the prefix that we have learned. So we have learned the 192.168.1 prefix via OSPF. And then we have 110, the administrative distance of OSPF. So there's our AD value. Here is the OSPF metric. Yeah, the metric value to get to this destination from our own router. And then the next hop that we will be taking to get there, how long this entry has been in our routing table, and the exit interface that we would use to get to that destination. So pretty neat that we get all of this wonderful information in one of our routing table entries. All right, well, all there is left to do for us in this exercise is grade it. So I'm going to go ahead and check my results. And sure enough, we did it, folks. We got 100% on this exercise, which was really introducing us to routing tables and dynamic routing table entries, but of course giving us a nice preview of some of the OSPF commands that we're going to get involved with later on. Thanks so much for watching, everyone.